Mẹ lên nào được không? Hả? Dạ. Hả? Con hỏi mẹ đi lên. Con hỏi mẹ đi lên được không mà. Mấy tưởng con hỏi cái gì, con hỏi mẹ đi lên được không? Yeah. Ờ. Huh? Yeah, because sub start. Yeah. May robiłam. Yeah.
All right, welcome everyone. Just give it another quick minute or two and then we'll get started. Feel free, if it isn't already, to pin my screen, and as always, turn on the cameras if we can. How's everyone doing today? Not bad?
Doing good.
Doing good? That's good to hear. Can you believe school starts in 1 month? That is so ass. That is so ass. I don't like school. What's tomorrow's bio class? Is it cell division?
Yeah, it is. It's a cell cycle.
Oh, all right. Oh, man.
Yeah.
I won't be there tomorrow, but Kevin might be.
All right.
Oh,
Ethan.
No,
I'm not joining.
We're not doing meiosis, though. We're just doing mitosis.
Yeah, do they cover that nowadays? I remember when I took AP Bio, they didn't cover it.
They do cover it now, but we're doing it in a separate class because.
Ah, okay.
Yeah.
It's probably good to space out. Do they still teach in middle school?
Meiosis?
Yeah, they used to teach both in middle school, I remember.
I didn't go to middle school in South Windsor, so I don't know.
Oh, that's right. Sorry, my bad. Yeah, they used to teach a lot in middle school. I remember they taught physics and simple machines and mechanical advantage and all that. But they changed it every couple years, so let me just focus the camera. Tech problems as always.
They taught protein synthesis in middle school, at least for me.
Really? What did they teach about it?
Kind of just the whole process, with tRNA, mRNA, and codons and stuff.
Oh, okay.
It was really repetitive, though. They did it for 3 months, and 2 of those months were just learning that A goes with T and C goes with G. And it was just.
Yeah, they slow things down quite a bit, but at least they taught it. I didn't know what that was until 10th grade. I wish they'd emphasize more of the math behind everything, though. A lot of times you get to the higher level class, a lot of math, and you're like, oh God, I wish I'd learned this earlier.
Kevin, get off your phone.
Welcome, everyone.
You get off your phone?
No.
Oh boy, we're tattletaling in this class. There, I'm gonna give it 1 more minute. How was swim today, Aaron? Did you have swim?
That was yesterday.
Was Ram still arguing with Karen?
Oh yeah, bro. I was in the car when they were fighting. We almost crashed into a car, man. I thought I was gonna die.
What was he even arguing about?
Oh no, Karen's just being a bitch.
Karen,
No, she got mad because Ram was just doing his job.
Woman moment. No, I'm just kidding. Something my roommate from college used to say. Sometimes when I'd get a math problem wrong, it's I'm just kidding. I'm just kidding.
Wait, Justin, is this your last class with us?
This is my last class with you guys. Yeah.
No.
We'll talk about it in just a second as soon as everyone's, I think everyone's just about here. Welcome, everyone. Welcome to class number 8. Where does the time fly? Because this is my very last class with you guys. All right, so I know things tend to get a little more hectic towards the end of class, so I just wanted to take the opportunity now to say thank you guys for being such a great class and such a great bunch of kids. You guys did a phenomenal job this summer. I am so proud of all of you as to how far you've come. What's Kevin showing on the... What is that? You guys might not realize it now, but you guys have learned a lot so far, and you'll be way, way ahead of when you get into AP Chem next year. What is Kevin watching? All right, so thank you guys for being a great class. Hopefully I'm not too hard to deal with, and it's been a pleasure to have been your teacher this summer. Now, that being said, there is still chemistry even after I leave. The other instructor, Gautam, very smart guy, will be reaching out to you guys in the next couple days to set up his portion of the class. I'm not sure if he's going to use Google Classroom or if he's going to stick with just email, but check your inboxes, check your email. This weekend, he's going to send some sort of announcement to get his part of the class together. Of course, once he switches over, he's going to be your primary tutor and teacher, but if you guys ever need anything, feel free. My contact is up here to send me a quick message or send me an email. You guys have my contact if you ever need anything. Chemistry or non-chemistry related. Maybe you need tips to study how to improve your SAT score. Pick
What
classes.
about mental health help?
That's got him. All right, and I will send out a quick survey. Maybe later tonight or tomorrow morning. Please do the survey I asked, because if I suck at my job, I might as well know it so I can improve for next year. It'll not only help you guys in the long run, in case you see me again, but it'll help next year's kids too, to get a better experience.
Dustin.
Yeah?
You're not about to be ready for my background.
Yeah. Oh, go ahead. Let's see it. Let it rip.
Well, we're loading it up.
Okay. We don't have the whole... Let's see.
I'll give it a shot.
Oh my...
Bro.
Oh my god. That must be...
Bro, get that out of here. This is a chemistry class, Kevin.
All right.
There's a lot of chemistry. See the way he's playing with his foot?
Save that for statistics class. That's bio. All right. Anyway, I wanted to... Any questions before we start about anything? The homework? Sorry for such a long homework assignment. But I saw a few of you guys post it online. It looks great for those of you that did post it.
I bet Aaron didn't.
Bro.
Okay, well, I'm not here to judge. So I want to start off with where we left off last time. There was one last page on last week's sheet that I didn't have time to cover. I know the camera, I can't focus on that. But it was the part where we started talking about KAs and PKAs. It says preparation for next class. This is the lesson 7 packet we did last time. So I just want to talk about a little bit about KA and how it's going to lead into today. So we talked about KA in lesson 6. Can someone remind me what KA is? Not all at once. Ka is the ratio of products over reactants in an acid-base reaction. That sound familiar? Today we're going to introduce a new quantity. It's called pKa. It sounds scary, but pKa is just equal to the minus log of Ka. That's all pKa really is. You take the value of Ka, you put it in the calculator, you hit minus log, put the value in, and that's the pKa value. Why is there logs? Yeah, we use logs in chem. What happens is because chemists are really dumb, lazy, stupid people who don't like to deal with big numbers. So what happens is, through magic, when you use logs, it turns really big numbers into really small, squishy numbers that are easy to deal with. All right? So that's why we use logs.
Squishy like my profile picture.
Yeah, squishable numbers that are compressible. All right, so now something else I want to talk about is what's the difference between pKa and pH? They're both talking about acids. So what's the difference? Here's the thing. pH talks about the solution. It's talking about the whole thing. pKa is talking about the molecule of interest. So I'll just reiterate again. pH is talking about the solution, which is talking about the concentration of free hydrogen, free H plus in the solution. Whereas the pKa is talking about the molecule of interest, the thing we're focusing on, whether it be HCl or HBr or HNO3. It talks about how good an acid it is and how likely it is to donate an H, how likely it will donate the H. Because remember, the definition of an acid is anything that donates the H. So an example might be you could have a strong acid, like a very strong HCl is a very strong acid. But if you just put one drop of HCl into a swimming pool of water, would you agree the concentration of hydrogen is going to be very low? There's not going to be a lot because it's so diluted. So in that case, the pKa would indicate that it's strong. However, the pH would indicate that it's weak because the pH is only talking about the solution, the whole thing, whereas pKa is talking about just this molecule. So pKa doesn't really change, but pH changes based on how much water you have. I hope that makes sense. It's not too important for today, but that might just be a little side note that'll come up. This will definitely come if any of you take biochemistry in college, where pH and pK is very important to know the difference. Can you guys see the screen okay?
Yeah.
Yes.
All right. I just wanted to review a couple basic rules before we move on. And I'm going to switch markers because this one's dying. Good timing, the last class to die. So, a couple of rules I want to remind you guys of. Or actually, you know what? We'll just jump straight in. This will work right into what we're doing. All right. So, last class. Last time we talked about titration, right? The lab technique, where we had a strong acid and a strong base. The key word from last time is that both things were strong. But now we're going to talk about titration, where one of the things is still strong, but one of the other things is weak now. Weak acid. One of the things is weak now. And this weak acid is going to cause trouble today. This is what changes our set of rules. Last time we learned how to do it when both are strong, but since one of them is weak now, we got to introduce a whole new set of rules. Fortunately, they're similar, but a little different in each way, which is what makes this class the hardest topic that you guys are going to learn in general chemistry. So I'm glad you guys are here today. Now, before we move on, I'm going to remind you of those rules I was going to talk about. Remember what we said last time? If the starting acid or base, I'm going to abbreviate them, is strong, the conjugate base and the conjugate acid is extremely weak. So it has no effect on the solution. If the starting acid and the starting base is weak, then the conjugate base and conjugate acid is decent. Decent meaning it will affect solution. It will affect the pH of the final solution. So last time we dealt with this, where both were strong, so we didn't have to worry about what the conjugate acid, conjugate base did. But now that one of them is weak, now we have some troublemakers that start to change our solution. So let's jump straight into business and talk about strong base and weak acid titration. So I'm going to draw my little picture from last time. All right, so when you titrate a strong base with a weak acid, the strong base goes in the burette. So this is the base, the strong base. Goes in the burette. Maybe I'll switch colors. And it gets slowly dripped into the flask. And inside the flask, we have the weak acid. All right. So now recall that last week, when we did strong base, strong acid, we didn't have to worry about the conjugate base and the conjugate acid having effect on the solution. So why is that? Because rule number 1, if the starting thing is strong, the conjugate is super weak. Which means that last week, when we had H plus OH, the acid and the base, reacting to form water, there's nothing else in the solution to affect the pH besides the starting acid and the starting base. It's just water, and water doesn't affect our pH. But then when we have a strong thing mixed with a weak thing, now the conjugate does have an effect on the solution. So the formula we're going to use today is HB plus OH goes to H2O plus the conjugate. So this is our starting acid. This is our starting base. Just like before, but they react to form H2O. And look what they also form. It forms a conjugate base. It forms a conjugate ion. And this is what's producing trouble. This will affect the pH at the end. All right? So now since this has an effect on the final solution, now we have to use equilibrium. Everybody's favorite topic, right? So that's the answer in the first box, or the first couple boxes. Equilibrium. Any questions so far? All right, so if I get too carried away, feel free to stop me at any time. In every strong base and weak acid titration, there are 2 different reactions that take place. 2 different reactions. I did not realize that when I took AP Chemistry, and I did not realize that when I took college chemistry until towards the end of the year, actually. But there are 2 different reactions that are going on. And I remember in college walking out of the lecture hall saying, oh my God, this is so bad. But with time and effort, anyone can learn this. So the 2 different reactions. The first reaction is the neutralization reaction. The neutralization reaction. And what happens during this is that the acid and the base neutralize each other. Meaning they produce water, just like before. That's the first step. And that's the only step that happened last week when they were both strong. This week, since one thing is weak, there's a second reaction. After the first reaction finishes, we have an equilibrium reaction. And what that means is, if we look back here, you see this thing? The conjugate base I talked about earlier? This is what causes the equilibrium reaction. So since we produce some of this every time we react, this is what causes the reaction to start shifting left and shifting right again, and shifting left and shifting right. So we have to use equilibrium to see where everything levels off in the end and what the average concentration is. All right? So I'm going to show you guys how to do that. Any questions so far? The black marker is dying, so it looks like I have to write in blue this time. You guys can see blue okay, right? So, all right. I'm going to start off with, let me show you this. Do you remember a titration curve from last time? On the x-axis, we have the volume of base we added. On the y-axis, we have the pH. So we're going to start off here. This is before the equivalence point. All right. So we start with our acid in the flask. We're slowly adding base in, and as we're slowly adding base, as we're slowly dripping it in, the pH is slowly rising, just like before. So these are going to be the steps you use before the equivalence point. Before the equivalence point. So that's the first box we have right here. All right, so the first example, actually, I don't like blue. I'll go with black until it dies out. You have 0.05 liters of 0.1 molar HC2H3O2 in a beaker. And you add 0.01 liters of 0.1 molar NaOH. So, as a reminder, the equation we're going to be using is this. Hb plus OH goes to H2O plus B minus. This is our starting acid. So this is Hb. This is our starting base. So this is OH. All right. You see how I'm taking these materials and fitting them into our general equation? All right. So I tried to spell out the steps on the side for you guys. So the first thing that's going to happen is the neutralization reaction. So all of this that's going to happen below is the neutralization reaction. That's the first thing that's going to happen. So step one is to find the moles of acid and base. So fortunately, this is very similar to what we did last time. We have 0.01 liters of NaOH, and we're going to use the molarity to convert it. 1 mole of NaOH. And we know that for every 1 NaOH we have 1 OH. So when I put that into my calculator, I get 0.001 mole of OH. Does that make sense? Now we're going to find the starting moles of acid. So we have start with 0.05 liters of HC2H3O2. I have no idea what that acid's called. And we're given that it's 0.1 molar. It's going to be a pain to write every time. All right, so now we got to moles of this. But notice, since the acid is weak, we can't break it up into H. Notice how for the base, since the base was strong, we were able to break it up into OH, because for every 1 NaOH we have 1 OH, because every single molecule breaks up. But for the acid, we can't do that, because since it's weak, not every single molecule splits up into H. So we don't know. So all we know is we have 0.005 moles of acid. And the acid is like saying HB. Any questions so far? So that's where we're starting with, all right? Step 2 is to write the equation. So I gave you before, the equation is HB, the starting acid, plus the strong base, produces H2O, and then the conjugate base. So there's our equation, which is going to lead us to step 3, which is going to be the mole rice box. So do you guys notice how so far it's the same as last time? Just a minor difference. We couldn't split up the acid, but so far it's the same. So we're going to start with our rice box. We're going to write the reaction up top, H2O plus B minus. And now we're going to plug the numbers in. So we start with this much acid, 0.005, and we start with this much base, 0.001. We don't care about water, because remember, we don't include that in equilibrium. And we start with 0 of the conjugate base, because all we did at the start was dump acid and base together. We didn't have any of this. Now, which one is smaller? Base or acid?
Base.
Base, right? So just like last time, we're going to let this go to 0. So I'm going to subtract 0.01 from both of these. And so far, it looks the same, right? But wait! Since we produce conjugate base this time, if we subtract 0.01 from the left side, we have to add 0.001 to the right side. Because for every time we react this side, we produce some stuff on this side. Last time we didn't have to worry about that because all we produced that time was water. But now, since we produce something else besides water, we have to account for that. So now this goes to 0. That's gone. This goes to 0.004. And this is 0.001. Any questions so far? All right, I'm going to try to make space here. All right, step 4. Step 4 is to find the molarity of everything. So we're going to do what we did similar to last time and divide everything by the total volume. So we ended with 0.004 moles of HB and then 0.001 moles of the new conjugate base. And we have to divide both by the total volume. So we started with 0.05 liters and we added in 0.01 liters. So we're going to divide both of these by that. So now for this, we get about 0.0667 molar of acid.
I have a question.
Yeah, go ahead.
Why do we divide it by the total volume?
Because we want to find a molarity. We want to find the concentration. So remember how molarity is equal to moles divided by liters?
Oh, yeah. Okay.
Yeah, so we have the moles up here. Now we just have to divide by liters to get molarity.
Okay.
Good question. Good question. And we get, on this side, we get about 0.0167 molar of the conjugate base, B minus.
My geo grade.
B minus, yeah, your geo grade with Mrs. Mazzona. Or no, Mrs. What's that lady? Mrs. Farrell. All right,
Would you
so.
like to say what you thought of Mrs. Farrell?
Miss Farrell. Yeah. All right, so now we got to this, right? What we did was we started with some acid. We added some base in. The acid and base neutralized each other, and we got to here. That's the end of the neutralization reaction. Now comes the second phase, the equilibrium reaction. So notice here we're left with the starting acid and the conjugate base we produced. This is what's going to shift our equilibrium back and forth. So now, do you remember how last time we had a formula, pH equals minus log H, and we could just plug in? Well, that doesn't work this time because we have two things. We need a new formula to account for the effect of equilibrium. That takes us to step 5. We have a special new formula I'm going to introduce, a magical formula that not only gives us the pH, but it also accounts for the effect of equilibrium that's happening right here, which is pH equals pKa plus log of the conjugate base divided by the weak acid. And by magic, that solves all our problems. If you want to know why it works, you
What
can
about my
see
mental health?
your mental health. Sorry, math can't solve that. It's one problem math can't solve. So now,
Or
okay,
opioids?
we have to see what we know here so we can plug into this formula. We know the amount of conjugate base, right? That's this number. So we can plug this up top. And we know the amount of starting acid. That's this number. We can plug in here, right? All we need now is pKa. Well, pKa, remember, is minus log Ka. And they gave us the Ka at the beginning. So step 5 is the tedious step. We simply plug everything in. pH equals pKa, but pKa is minus log of Ka, which Ka was 1.8 times 10 to the negative fifth, plus the log of the conjugate base, which is 0.0167 divided by 0.067, which is the acid. So now I'm going to put this into the calculator slowly so you guys can see where the numbers come from. When I plug this in, I get 4.74. When I plug this in, I get, oh God. What did I get? Get about minus 0.6. And when I add 4.74 to that, I get about pH is equal to 4.14. And there's your final answer.
Wait, why do we do a positive log for the second part?
A positive log? It's because you see how this, in this case, the denominator was bigger than the numerator? So that made the whole log negative. So then adding the negative is just like subtracting. Which means, there's a theory behind it, which means there's more acid than base. So more acid brings the pH down. So that's why we have to subtract it from the starting amount. It's all mathematics. The chemistry is just plugging in the numbers, but the mathematics is why it actually works. Which you don't have to worry about for AP Chem. Any questions? All right. Anyone need to see any part of it again? Oh, why is it so blurry today? All right. So I don't mean to scare you guys, but that was the easy problem. I told you this class was not going to be fun. Anyone have anything I can answer before I move on? I don't want to see people get lost. All right, so we took care of what happens before the equivalence point. Now we keep titrating, we keep adding more of the base, and now we get to this part right here. This is the equivalence point.
The what?
The equivalence point. And remember, at the equivalence point, the moles of acid equals the moles of base from last time. So now I'm going to show you guys how to find the pH here in the equivalence region. So this is at the equivalence point. I'll abbreviate it. Now everybody take a deep breath. This is going to be the most complicated problem we've had this year. Okay, so, but there are a few shortcuts we can take. Everything is the same until step 5. So if you could do the first 5 steps, yeah, of the last problem, it's the same up till there. Now, here's what's going to happen. If we look back at our general equation that we've been using today, at equilibrium, the acid and the base run out at the same time, right? And we had an analogy for this. If you eat your rice at the same rate as you eat your curry, they run out at the same time. So this goes away and this goes away. Last time, if those two went away, all we had left was water, right? But now we have this left, the conjugate base. And this is what I said. This is what I meant when I said the conjugate base causes trouble. This will react to affect the reaction. Since H2O, water, is not the only thing left, but we also have this sucker right here. This will change the pH further than the acid and base already have. All right, and something else that you guys have to keep track of this time, we have 2 different rice boxes. So this is the first time we have to use a rice box 2 times for the same problem. All right, so let's begin. Lord have mercy, this is going to be very tedious. But hey, look on the bright side. If you guys can survive today's class, there is nothing you guys can't do for the rest of the summer. Because Gautam's section of the class, the other instructor, his section is easy compared to this. So if you guys can handle this and follow along, you guys should be set. All right, so the first step, remember, it's the same start as the previous problem. Step 1, we start with the neutralization reaction. So the first step is to find the moles of acid and base. So, like last time, let's have the boys find the acid, and let's have the girls find the base. And somebody shout it out when you're done. And Kevin, if you're non-binary, you do both. All right. Let's see. We have an answer for the acid. All right, what did the boys get for the acid?
Is it 0.005?
0.005. I like it. Yep. So moles of the acid. So the HB. Good job. All right, girls, what did we get for the base?
I got 0.005.
Correct. Good job. Moles of base. And it makes sense, right? Because we're at the equivalence point. These two are equal. All right, so step 2 is to write our equation. HB plus OH goes to H2O plus B minus. Step 3 is to set up that rice table. So the first rice box we're going to use is a mole rice box, where we plug moles into it. So I'm going to write our reaction. So we start with 0.005 moles of acid and 0.005 moles of base. We don't care about the water, remember, and we start with 0 of the conjugate base. So we're going to subtract the same amount from this side because they both run out. They go to 0 at the same time. And we add 0.005 to this side. So we end with 0.005 moles of the conjugate base, all right? And then just like before, and just like last week, step 4 is to find the molarity of whatever you have left. So remember, molarity equals moles divided by liter. And we just found the moles of the conjugate base. So now we just have to plug in. So molarity equals 0.005 divided by the total volume. So we added 0.05 liters plus 0.05 liters. And when we plug that into the calculator, we're getting about 0.05 molar of the conjugate base. Are we good so far? So that was the neutralization reaction. So the acid and base neutralize each other, produced some of this, the conjugate base. And now this conjugate base at equilibrium, it's not happy yet. It's going to drive us again to the left and then again to the right and then to the left and left and right again. So now we have to use equilibrium to figure out where it's going to level off. So this next part is the equilibrium reaction. Sorry about the handwriting. This is step 5. All right. So do we all agree that at equilibrium, I'm going to circle that part of our box. Do we all agree that at equilibrium, the only thing left is the base? Now it's going to do exactly what it was born to do. It's going to be a base. So now there's nothing left for it to react with, right? Because everything else was used up. So you know what it does? Of all the things it could do, it could just kill itself and we could end here. But of all the things it does, it reacts with water.
I'm suicidal.
Suicidal, yeah. Well, this is something different from suicidal. It's using another molecule greatly against its will. So it grabs onto water and reacts with it, whether water likes it or not. So this is our new... I don't want to say it like that, but if it helps you remember it. Now, if we look at this reaction, if we look at this new formula, do you notice how it's just the opposite of the one we used before? So it's driving the reaction the other way now. So that's step 5. We know that this is what we're going to use from now on. Step 6 is to use a rice box, another rice box. Now, this is different from the first rice box because the first rice box dealt with neutralization. The second rice box deals with equilibrium. So for this rice box, and I'm going to write it in big red ink, you must plug in molarity, not moles. So molarity this time. So our reaction is going to be H2O plus B minus goes to HB plus OH. So we don't care about water, remember, but we're starting with 0.05 moles of the conjugate base because that's what was left after the first neutralization reaction. And we start with 0 of this and 0 of this. So now we treat this like a regular icebox. We're going to subtract X from this side, but we're going to add X to this side. Because every time this is reacting, it's producing this. So at equilibrium, we get 0.05 minus X, and then we get X on that side. So we're producing our starting base and acid again. Isn't that weird? We used all of the starting base and acid up, and then now we're producing it again. So now, are we good? But we're not done yet. Oh boy, this problem just keeps going on and on. Step 7 is to use Kb because we have to use Kb to find OH at equilibrium. So if we recall from last couple classes ago, I even put it on your sheet for you guys. Kb is equal to HB times OH divided by B. Remember the products over the reactants. So we already know what KB is because it gave us the value at the start of the problem. And we know what all this is because we wrote it in terms of X at equilibrium. So now all we have to do is plug in. So KB is equal to 5.6 times 10 to the negative 10, which equals X times X over 0.05 minus X. So I'll just turn this to X squared. Now we're going to solve for X. And just so I don't have to solve a quadratic, I'm going to get rid of that X. And when I put it in the calculator, I'm getting X is equal to about 5.29 times 10 to the negative 6. So we got there. Notice how at equilibrium, OH is equal to X, right? So that means now OH is equal to 5.29 times 10 to the negative 6 molar. And once we know OH, that's step 8 now, we can find the POH by doing the minus log and putting that number in. So when I put that in the calculator, I got POH is equal to about 5.28. And since pH plus POH equals 14, the pH equals 8.72. And that's our final answer. Wow, can you believe that? That was all one problem. Any questions at all?
Wait, why do we switch into molars again for the second?
Because
Let
for
me
the
copy. Hold up.
because for the second icebox, that was an equilibrium icebox. And in equilibrium iceboxes, you have to use molar. It's because we're dealing with concentrations. So we have to write everything in terms of X, and we have to be in molarity.
All right.
For the rice box, like, why do we minus X, but then we add like a total of 2X on the other side?
It's because on the reactant side, for every time we use up one of this, we're going to produce some of this. So the reactant side has to go down, so it's minus, but then the product side has to go up, so it's plus.
But like, why do you add X twice on the right side?
Oh, why do you add it twice? The left side doesn't always have to add up to the right side. Because if we look at the reaction, none of these pens work. You see how this H on water gets ripped off and stuck onto the B minus? So after this reacts, we're left with an OH and with an HB. So that's why we have to add X twice to account for 2 ions that we produce by this reaction. That kind of makes sense?
Yeah.
I know it's confusing, right? All right, are we good copying? Anybody totally lost? Like totally lost?
Me.
Me? Oh boy. Which part?
I'll just look at the recordings later.
You okay? I can help you after class too if you need a total refresher. All right. So, any other questions? All right. The very last problem, I promise, for the whole portion of my class. All right. So we dealt with what happens before the equivalence point, at the equivalence point, but then once again, we were on our phone in lab and we kept adding base. We overshot it. Now we're in this region right here. This is after the equivalence point. Fortunately, we can still find the pH with some math. And fortunately, it's easier than what we just did before. All right? So now, let's get to it. So this is after the equivalence point. After the equivalence point. So everything is the same. All right, so this is the last page. Same up till step 4. And at this point, remember, we overshot the reaction, so the acid runs out first. I have good news for this reaction. There is no equilibrium. There's only a neutralization. We only have a neutralization. And I'm going to explain why when we get there, but just keep that in the back of your mind while you're doing this. So, our problem, we have 0.05 liters of 0.1 molar HC2H3O2. The Ka and Kb are given. And then we add 0.06 liters of 0.1 molar NaOH. And we want to find the pH. So, this is our HB, our starting acid. This is our OH, our starting base. So, step 1. What's the first thing we always do? Somebody shout it out.
Moles.
Moles, right? Exactly. So find moles of H and base. So let's do it again. Girls, why don't you do the acid this time? And boys, why don't you do the base? All right. So find that, and then whoever gets it first, shout it out for me.
For the base, is it 0.006?
0.006. Correct. That's exactly what I got. Good job. And then the acid. Any girl want to take a shot at it?
0.00.
0.005.
Yes, that's correct. Thank you. Thank you both. Kevin, I thought you were non-binary though.
Yeah, I'm answering for both.
Oh, that's nice. Give everyone a break, right? All right, so now, are we good with step 1? Step 2 is to write the equation. HB plus OH, it's the same thing we've been using so far. H2O plus B minus. All right. And step 3 is to use up our rice box. But we're going to use the mole ice box, so we're going to plug moles into it because this is a neutralization reaction. So neutralization reactions use mole ice boxes. I start with 0.005 moles of acid and 0.006 moles of base. And 0 of the conjugate base. Which one's smaller?
0.005.
0.005, right? So the acid runs out first. And we're going to add 0.005 to the other side too. So we're left with 0.001. All right. So look what we have at equilibrium. We're left with 0.001 moles of the starting base. The starting base, which is OH. And we're left with 0.005 of the new conjugate base, which is B minus, all right? I shouldn't drop bars. All right, so here's what happens. We have 2 bases left, right? Now what happens is, even though, and this is the key point right here, even though at the end we're left with 2 bases, since the starting base, the OH we added, is so much stronger than the conjugate base, the B minus we produced, we're going to ignore the the B minus. You just get rid of it. Why the hell do we do that? I have an analogy for you guys, and you know my bad analogies. So let's say we have some guy that looks like this, okay? This is our B minus right here. You see the guy's like kind of big, kind of chunky like that, but you know, like average American nowadays. So that's the base. It's strong, but you know, nah, not the strongest. Let's say we have this now. This is our OH minus. Really strong, really big. Would you agree that they're both bases? Because it's all about the base. That's what we're talking about here. All about the base.
Yo, if she falls on me, I'm dead, bro.
Bro, what the fuck?
But would you agree this one is so much stronger than this one? That this overshadows this one. This makes this one look small. So what happens is, if you just think about it, you're going on the street, you see both people, which way is your eye darting? Like, which one are you looking at? So this one overshadows this one because it's so much bigger and so much stronger. You do not see the other one. It was either that one or that one. I couldn't tell which one. I couldn't tell which one I like better. So they're both
Yo,
OHs.
I'll pick the other one.
So the OH overshadows the B minus since it's so much bigger and stronger. All right. So we forget about the B minus. Sorry, B minus. And I'm almost out of. I got 5 minutes left. So what happens is we got rid of this, the B minus. We just crossed it out because it's overshadowed. It's covered up by the stronger OH. So now we have 0.001 moles of OH because we're ignoring the other thing. Step 4 is to find the molarity. And remember, molarity equals moles divided by liter. So we have moles here, and now we have to divide by the liters that we started with. So it's 0.06 liters plus 0.05 liters. So I'm going to put this into the calculator, and I'm getting about 0.0091 molar of OH. We have an OH concentration. So look what we can do now. We can find the POH, which equals minus log OH. So POH equals minus log 0.0091. And when I put that in the calculator, I get POH equals 2.04. And once I get POH, since pH plus POH equals 14, I can now plug in for pH and get pH is equal to 11.96. Congratulations, you've survived titration. That is our final answer. So remember, when we have 2 bases, after the equivalence point, one, the stronger one, will mask the other one.
Bro.
It will capture all of your attention, so you don't even have to focus on this one. Just like when we're walking in public. All right, so that is the lecture for today. If you look on the next page, you'll notice that there's no homework for this week. All I gave you was the worksheet. So since you have a new instructor next week, I won't be here to go over the answers if I did give you homework. So all I give you was a worksheet. I'll post the answers to the worksheet after class. You guys are free to stay around. I will send an extension link in case you guys have any more questions, want me to go over anything again. But thank you so much for a great start to the summer. And I hope you guys, even after the next instructor comes in, I hope you guys take some time to enjoy your summer and relax before school starts next year. You guys have done great this summer. I appreciate you guys showing up every, what is it, Thursday, Monday evening just to talk about chemistry. And you guys have done a phenomenal job. You guys rocked it out. All right? Awesome job. So
Bye, Justin.
hi, Aaron. Thank you for coming. So
Thank you,
Thad-
Justin, for being a good teacher.
Oh, thank you too. Thank you for putting up with all my bad analogies.
I just killed that mosquito, Justin.
Oh, we're killing mosquitoes now? All right, the call's going to kick me out, but I'll send an extension link and stay around.
Good night.
Good night.
Suck my dick. Alright, that's the rest of it, man. Yo, is this shit finna open, bro? Oh, man.